1. Difference of squares on the bottom. Non-permissible values. X can't equal -3, and x can't equal 3. Do you notice the x plus 3's are identical? Oh, just 1 second. This is interesting because the x plus 3 cancels out. That means we're going to have a whole. But the other one doesn't cancel out. So we're going to have the whole at -3 comma something, but the other one doesn't cancel out. That leaves a vertical asymptote at x equals 3. Whenever you have a whole, that's where that green thing in our steps comes in, and I always write it in green. Write the new equation. What's the new equation? And careful. The number one thing I see as a mistake here is students just write x minus 3, because everything canceled out. But the problem with that is the x minus 3 is where? It's in the denominator, so we have to keep it in the denominator. And what do? Nothing's left on the top? A 1. So careful, if you see this, you might be tempted to just graph a line, because you think only the x minus 3 is left, but this x minus 3 is left in the bottom, which means we still have a rational equation and still have to do steps 3, 4, and 5. So does this new equation, okay, now we no longer go back to the original, we base everything on the new equation. Does the new equation have any horizontal or oblique asymptotes? Yes. The degree is bigger on the bottom. Anytime it's bigger on the bottom, you have a horizontal asymptote at y equals 0. You would have got that, notice it's still true based on the top one, but you have to be careful. You have to base everything on your new equation, and I'll show you why. When we get to our nice points, for example, the y-intercept, if you plug in 0 for x, you get 1 over -3. Would you have got 1 over -3 in the original? Yes. So it seems like, why can't I use the original? But for the x-intercepts, in the original, you would say, at -3, I have an x-intercept, because that would make it equal to 0. However, in our equation, there are going to be none, because in this one, there's none. We also never finished our whole, right? So if I plug in -3 into my new equation, I'm going to get 1 over -6. Is that what your hand was up for? Thank you. So now, based on what we have so far, we have to put in a vertical asymptote at x equals 3. So we have a horizontal asymptote at y equals 0. We have a y-intercept at 0, -1/3. There are never any x-intercepts, and we have a whole at -3, -1/6. That's enough in section 1 to graph a point. I can plug in a +4 into my green equation. Never go back to the original one. Now we go to the green one. And that will be 1 over 1, which is just 1. So now we have a rational graph with an added whole. I find that the provincial exam really likes questions like this one, because they match up with what You're still got a rational graph to graph in the end, but you add a hole to it. So they really like to add the hole to something you already know how to graph.
Alright, so this one you have question 4 plus what?
In this one, the practice question to do that's similar is the one on the construct the understanding. And number 6 is good practice, but it actually doesn't have a hole in like this one. It's a little bit different. But the construct the understanding is really good for this. Did it say domain and range?
Yeah.
Oh, well, you can see the domain x can't equal 3, the range y can't equal 0. Ooh. You know what? Here's interesting. This is interesting. I thought the domain was boring, but it's not. X can't equal 3. The range, well, the domain is boring. But the range, it doesn't go through 0, but it also doesn't go through -1/6 because of the hole. Oh, and they also have the domain doesn't go through -3. So it's a little bit crazy.
Why didn't it go through -1/6?
Never. Because the hole is at -1/6 and this keeps getting higher and higher. Hits that, skips over it, and gets higher and higher that way. So a little bit tricky for the domain and range there.